All right, so let's continue our discussion of maximums and minimums in section 4.3. At the end of the last video, I defined a critical point for you. So let's revisit that as a way of review. Let C be in the domain of f of x. We say C is a critical point of f if either f prime of C is equal to 0 or f prime of C is undefined. And these were these places where we had potential maximum and minimum values. Okay, so let's identify those points from a graph. So chapter 4, graph number 7, it's got lots of weird looking places on it. And we're going to look for places where the derivative might be equal to 0 and where the derivative might be undefined. Okay. And the derivative is going to equal 0 any place we have a horizontal tangent where we have that slope equal to 0. So we've got one of those places over at -6. And maybe a little bit sneakier is here at x equals 0. Kind of looks like the tangent line goes completely flat just for a moment. Right. So those give us two places where the derivative is equal to 0. All right, and we have also places where the derivative is undefined. Okay, so remember that the derivative is undefined at any place where there's a corner or a cusp. And so those are two places where the derivative is undefined. Doesn't exist. And we have a fifth place where we have a critical point, and this one again is kind of sneaky. There's a place over here at x equals 7.5 where the tangent line looks like it goes completely vertical just for a second, where f prime of x is going to not exist. Okay, so our critical points are just going to be the x values where this happens. So our critical points are x equals -6, -3. If I go left to right, we found one at 0, x equals 2, and x equals 7.5. Okay, so most functions don't have that many critical points and that many weird ones, but we just kind of wanted to review how we could get critical points. Okay, so we can also calculate these from looking at the formula of the function. Okay, so we'll just keep that definition in mind, that a critical point means that the derivative is equal to 0 or undefined. And for most of the time when we say undefined, we're going to mean division by 0. All right, so let's take a look at the derivative of this function. This one's pleasantly easy to take the derivative of. So power rule. And we want to know where this thing is equal to 0 or is undefined. This function is never going to be undefined. Undefined is going to be caused by division by 0. So we really only have to worry about where it's equal to 0. All right, so that's a quadratic equation. If you want to solve a quadratic equation, you either need to factor it or you need to use the quadratic formula. And I do not care which one you use. This one factors, and that's faster, so I'm going to do that. Let's see, I need plus 3x and minus 1x to give me 2x. All right, so I factor it, and then I set my two factors equal to 0. So I'll add 1 to both sides over here. Divide by 3. Over here, I'll subtract 1 from both sides and get -1. All right, so this function has two numbers that make its derivative equal to 0. -1 and 1/3, and those are your critical points. By the way, I might mention that the terminology is a little odd. We say critical points, and usually when we say points, we mean like an x comma y for a point. When we say critical points, we're just talking about the x coordinate. So that's a little bit of a misnomer, but it's one that we're kind of stuck with. All right, so let's look at one more. Let's find the critical points for this function. F of x equals the cube root of x squared minus x. All right, so I'm going to rewrite that so it's easier to take the derivative. I'm going to write that as x squared minus x to the 1/3 power. All right, so we're going to need the chain rule here because we have an inside function and an outside function. So I'm going to take the chain rule. We're going to take the derivative of the outside function, which is bringing down the 1/3. And 1/3 minus 1 will give me -2/3. Leaving the inside function alone. Multiply by the derivative of the inside function. All right, so this was the point when we were learning derivative rules where everybody asked, do I have to simplify? Do I have to simplify? Here's the point in life where you're going to want to simplify, because I need to figure out where this thing is equal to 0 and where is undefined. And it looks like a hot mess right now. So I'm going to take this thing and move it down into the denominator with this 3 here. And that leaves me with a 2x minus 1. And the 3 is down in the bottom, and so is this x squared minus x, now to the positive 2/3. All right, so I need to figure out what makes this thing equal to 0 and what makes it undefined. Okay, so this fraction is going to be equal to 0 when the top is equal to 0. Okay, so the whole thing is equal to 0 when 2x minus 1 is equal to 0. Because if I make that big red circle equal to 0, 0 divided by anything would be equal to 0. Okay, so that's going to be what makes this derivative equal to 0. So that's easy to solve. Add 1 to both sides, divide by 2, and we get x equals 1/2. All right, but this derivative is going to be undefined when this whole denominator here is equal to 0. All right, so to solve that, I'm going to, first of all, divide both sides by 3. That 3 is not going to contribute much of anything. And then I've got this x squared minus x to the 2/3 equals 0. And there's a couple of ways to solve this. I'm going to rewrite that as the cube root of x squared minus x quantity squared. All right, and then kind of to unpack this, I can get rid of the cube root by cubing both sides. X squared minus x squared equals 0. Then I'll take the square root of both sides. So I get x squared minus x equals to, usually we'd put a plus or minus, but it's just equal to 0. Okay. And then I am not going to divide both sides by x. That was something that was some of your favorite things to do on your exam. You don't want to do that. You want to factor an x out over here on the left. Okay, because you actually get 2 solutions. If you divided both sides by x, then you would get only one solution. You'd be missing the other one. So set both of those factors equal to 0. And you get x equals 0 and x equals 1. Okay, so our critical points, we had 3 of them. 1/2, 0, 1. So our critical points are x equals, let's put them in order, 0, 1/2, and 1. All right, so again, finding critical points, we want to set the derivative equal to 0 and figure out where it's undefined. Okay, so we'll continue with another example of that and then sort of apply this to the idea of absolute maximums and minimums when we meet together on Zoom for our class. See you then.